Hi class. This example is going to deal with water waves. It says, in California, Steve-O is surfing on a wave that propels him toward the beach with a speed of 5.0 meters per second. The wave crests are each 20 meters apart. What is the period of the water wave? And then Steve-O is this guy from a very famous MTV show. You may not know it, but that's fine. So, let's cover up the variable that we want, which is period, that is tau. So our hand with a glove, pandemic mode, we cover up tau and we have 1 divided by the frequency. I don't think you would need to use the triangle because the equations for frequency and period are very simple, I believe. But it's just good practice to know how to use the triangle. We need frequency. However, it's not explicit on the problem. So this is a two-step problem because we need to find the frequency and then use our answer to find the period. So second hand, and then we're going to cover frequency. That's the one we want. Now we can see that velocity divided by wavelength equals frequency. Let's write the given information. Now if Steve-O is on the wave and is moving at 5 meters per second, the speed of the wave is 5 meters per second. So velocity equals 5.0 meters per second. And we have lambda. How do we know lambda? Remember, the distance between crest and crest is the wavelength, and that is 20 meters. They're separated by 20 meters. And our equation said frequency equals velocity divided by wavelength. Just substitute frequency equals 5.0 meters per second divided by 20 meters. Now let me clear this up. 5 divided by 20. That is 1/4. If you want to see it numerically, 0.25. So we write frequency equals 0.25 hertz. Now we can use our equation for period. Tau equals 1 divided by the frequency. That is 1 divided by 0.25 hertz. That would be 1 divided by 0.25. The answer is 4. Period equals 4.0 seconds. And that is the answer. Remember, when we are using the triangle, just cover up whatever unknown you're going to solve for. That is it, guys. Bye.